Hello everyone. Today we talk about Apache Hive. In today's session we will be covering its introduction, then we will be comparing it with RDBMS, then we will talk about its component. We will be covering and showing you Apache Hive on Hortonworks cluster Sandbox. So let's take a look at that. What Sandbox offer to us. I already downloaded Hortonworks Sandbox from Hortonworks website. In downloads, you can download that Hortonworks Sandbox cluster. If I just take a look at that, right now it's in running condition. So if I just go to its dashboard, then I just need to click on Hive. You might able to see few components listed here. We will be looking into that, and we will talk the initial introduction of in today's session about these. Let's go on slide deck what exactly we can see here. So it's the first slide we're gonna cover about introduction of Hive. What is Hive? If somebody asks me that question, I can simply say that it's a database. But in overall condition, it's not a database because it's not an RDBMS. It does offer you the SQL capability to write an SQL and get your result. But as we move forward, we will explain that what is the difference between a normal database and Hive and why it's been called as a data warehousing infrastructure base rather than a database. So if I take the first point, that is it's data warehousing infrastructure based on Hadoop. It's not a database. And what does extra things Hive offer? Table inside Hive is similar to relational database, which is accessed by SQL query language. That means that Hive does contain tables and you can query on it. But what exactly behind the scene, Hive stores all its data in HDFS file system. HDFS is called as an Hadoop distributed file system. This is a directory-like structure. So usually what Hive does, if there is a file behind the scene, Hive just put a schema on it. So Hive is associated with a read schema implementation. That's the major difference between Hive and a normal database. A normal database goes with the write schema implementation. So we need to understand between the difference of these two terminologies, write schema implementation and read schema implementation. Read schema is that you write in a file once and read many times. And at time of writing, the schema is not being adhered. That means schema limitation or schema data types or the table definition is not being implemented. If you have 10 column in a file and you did a schema definition with 9 column, it will not fail at the time of writing. Writing means that you are placing a file in HDFS. We will take a look at that once we will go forward. On other side, if we talk about the database, which usually talks schema implementation at right time, which means that you define the DDL first, and once you define the DDL and you tried to write something in it, if it does not comply according to the definition, it's gonna fail. And only the implicit casting usually does not fail. So that's the major difference between Hive and the other databases. So that's why Hive is not called as a database, and it's called as a schema at read. So what the purpose of designing Hive? We talk about in here in first step that Hive is a warehouse infrastructure based on Hadoop. It does offer you the SQL to execute on that. So that's mean that Hive is more kind of a database, but it's not exactly suited with the RDBMS definition, are not suited with the database traditional database definition. If we conclude that why Hive is designed, we can find it out that it's talk about in the warehousing, which means that it will look for large processing volume or large volume of data which can be processed. So one purpose is to analyze large volume of data. The other 2 points related to Hive design is easy data summarization and ad hoc querying. Once we have a quick way to write the data into HDFS, and then we can able to do a query, it does give you a chance to write a query on it and do a good summarization to extract your required result. This is what Hive does offer us and what is the purpose of designing Hive. So let's compare Hive with an RDBMS. RDBMS is a relational database management system. So we do have a lot many RDBMS available in the market, like Teradata, like Oracle, like MySQL, or there are a number of them is available, and most of us might have already used that. But what exactly the difference in it, we will take a view of those critical points and why Hive is called warehouse, not a database. So we already discussed the first point that Hive isn't a database, so it's just a warehouse. Hive enforces schema on read time, whereas RDBMS enforces schema on write time. We already talked about that. On read times means you can write whatever you want in case of Hive, but later on once you try to read it, if it does not comply with the schema, query gonna fail, or query gonna show you null in it, or null in the columns. And but in other cases, an RDBMS query cannot be executed, or if you try to write something which does not comply according to DDL, it cannot work. So in Hive, in here, we can write earlier and later on we can define as well. So we will see that how it can be done. There are some external and internal table which is called managed table and unmanaged table in Hive. So in case of that, we can write earlier but does not have DDL definition, and we can define DDL definition later on. So it's totally a different structure, different way of doing things in Hive. So Hive is based on the notation of write once and read many times, but RDBMS designed for read and write many times. So it's more kind that Hive you write it once and read many times, because you are expecting that big data size to be write once, and then you just do a reading like a warehouse that you just need to build it for later on for summarization, for doing your ad hoc queries and extracting the data out of your Hive DDL which is being written on a file. Our next point talks about the RDBMS is a transactional based system, and Hive is not a transactional based system. Hive usually associated with a warehouse, and warehouse talk about large volume of data size. So Hive is always talk about the batch processing kind of application. So it's not a transactional based system. What is the difference between the transactional based system and non-transactional based system? Transactional based system offer you row level updates inserts, delete, and you can place some indexes on it. But on the other side, Hive does not offer you to do update, inserts, and delete. You should be writing everything in a batch format, and once you have to do updates, you have to do it from dropping a table or creating a new table from the same data. So it does not allow you the transaction based processing system in normal conditions. So if Hive newer version does have the transaction processing capability, but it is not intended to use for that specific purpose. So if, as I told you all this, RDBMS record level update offers you record level update, insertion, deletes, and transactions with indexes or possible. Whereas these are not allowed in Hive because Hive built to operate over HDFS using MapReduce, and full table scan is a norm, and table updates can be achieved by transforming data into new table. That is what I talk about, that if you want to transform something, then or you want to do some updates on the data, do some cleansing on the data, you have to do it in new table and use select insert to get it done. So this is all about that. Then RDBMS's maximum size of data processing is in 10 terabytes of data, but Hive gives you a capability to have a data underline it around 100 petabytes easily, which means that it's more talks about batch processing. Writing is not a big issue, and then once you already write a thing, then because at time of writing nothing is being validated. So in case of RDBMS, number of checks is being validated, and in case of warehouse structure, it's always never been recommended to place some constraint in for RDBMS, but right now we are talking about Hive. On Hive, if there is no index is being offered in last point, we already told about that, then there is a least check is being done, and I already told you guys that it's a read on schema, so it does not apply any schema on time of write. So that's why it's easy to write a lot much petabytes of data, and later on it's just a read which is being done in a batch processing way, and mapper and reducer being used through MapReduce to get your transaction done. We will talk about in next upcoming session what is MapReduce mode and what will be the Taze mode, what will be the Blaze mode. So to access the Hive database, why I am calling database, because it's more associated with the database, because you have an capability to write it and SQL over top of it. But as I already told you, that it's not a database, it's a warehouse. So Hive, I already told you that it's a batch oriented processing system, so it's more closer to OLAP, online analytical processing, rather than is an OLTP. So it does not recommend you ever in till today's lifespan that it's an online transaction processing system. You cannot use that database for ATM transaction, for any source system. You always use it for batch processing, which is more closer to OLAP. These are the major differences for RDBMS and Hive, and why Hive is not associated with an RDBMS terminology, and it's what it's offer also. We already explained these things. So let's move to the components of Hive. What are the components of Hive? The major component of Hive is Hive Metastore, Hive Server 2, hCatalog, Web Hatchcat. So these are four major components which talks about Hive processing and which allow Hive to process the data. But if you see that there is no Hive server 1 is registered, so not written in it. So Hive Server 1 was a previous version of Hive Server 2. So it's already deprecated in current version of Hive, which has been used. Hive is already available. Now Hive 2 is there. We have Hive 1.3 previously. So there was many version has been available, and it's been improved regularly. So new version arrives, so something get changed, and something new is being given inside Hive. So if we talk about that, what is Hive Metastore? Hive Metastore is a data about tables of Hive. So Metastore does associate with the terminology of metadata. We already might have heard in RDBMS systems, which has been introduced in market way long, so everybody might have knew about that. That metadata talks about it's it's contain the information of the table or data inside the table. That could be the statistics, that could be the information, descriptive information of the table, what kind of DDLs is being built, and what is the column format, what is the column data type. These kind of information is talks about metadata in regular RDBMS. So in case of Hive, we have a metastore, which is associated to that kind of metadata storage. So for all Hive DDLs, it goes to metastore, and metastore insides associated with an RDBMS. So if we think that whatever we define in Hive, any DDL or any configuration or database has been defined, or database has been configured, or file location has been defined inside the table. So it goes in the DDL, and that DDL goes to Hive Metastore, and Hive Metastore storing everything in it in an RDBMS. It could be MySQL, it could be Postgres. Many database is being offered by Hive to store data in it. It is more likely to called as a repository, and that Hive Metastore, usually once we talks about that, we usually call it hash catalog. But once we go to the hash catalog section, which is there, so we will tell you guys that what is hash catalog and what is the purpose of hash catalog in it. So Hive Metastore is that, and now if we go with the Hive Server 2, this is something where you usually execute your queries against the provided file system. So this offers you the terminal where client can or user can run the queries, and this is usually called as a Hive client. We do have number of Hive client available, where one is a CLI based Hive client, one is Hive UI, which has been available in Mbari, and one is HD Insight, which is given by Microsoft to use behind Azure, once you are using Azure. And once we talk about AWS has got its own terminal to write queries on Hive. So we have number of different client available to access Hive capabilities. So this is talking about Hive server, and least but not last but not least, I would talk about that. Teradata does offer Teradata Studio to configure with Hive, and that's one of the very good tool. You can use that because it's more interactive, it's more working with an RDBMS. It does not give you flair that you does not have to control the columns of once you are writing a query on CLI based, and using web based Hive UI can also create problem because you are not used to it while connecting to a normal database, normal RDBMS. So once you are writing a query, you have to check the syntax and do number of things before executing that. So If you have a Teradata Studio kind of tool, it makes your job much easier. So what is Edge Catalog? Edge Catalog, built on top of Metastore, incorporates the component from the Hive DDL. That is the pivotal component in case of Hive, because Hive Metastore is usually not called everywhere, because Hive Metastore stores the data in a repository, which we already talked about that. But Edge Catalog is that component which gives you a chance to interact with Hive Metastore. So it's built on top of it, which gives you interface in communicating all the external component to Hive repository, and get your query executing. So storage management layer for Hadoop. So Hive catalogs hold file paths, metadata about Hadoop in Hadoop clusters. So it does allow you to run scripts through MapReduce job and decouple trace jobs, give you the data location and metadata schema, allow you to access that. Edge catalog also support like Hive and Pig. So it's that's Hive is a mode, and Pig we will talk about in later section. That what is Pig. Pig is just another application to use Hive database. So each catalog will help you in that. So behind the scene, how each catalog is doing all this stuff, it's offer you the API. Using the open API, each catalog external tool can be integrated like Teradata Astro, and leverage the path location and metadata in Edge catalog. So Edge catalog is the interface between Hive Metastore and all the external parties, all the external tools, which is usually is trying to access data from Hive. The last component of this one is Web Hashcat. Web Hashcat is being used by MapReduce or Yarn. Yarn is a yet another resource negotiator. MapReduce is more kind of a which offer you capability writing in Mapper and Reducer. We will talk about that once we talk about how Hive works, how Hive infrastructure gives you processing method. So we do offer the Hive jobs. We already told you that there will be Hive mode in which we will be discussing that. So using the Rust API, we can use Web Hashcat interface. So this is all about all its component. Let's see the flow of these component, how its interaction or the processing works in a diagram phase. So if I just go to next level, it shows me that how user can initiate a request from here, and then it could be either from MapReduce, it could be through Hive mode, through Pig. Inside it will be calling the Edge catalog components, number of different input and loader function they will be calling inside it. Edge catalog will be talking to this metadata repository through directly or through REST API, and these are the REST API clients from where they usually directly calls it. And what happened that it goes to REST API and Web Hashcat is being called, and later on all these gonna store the data inside HDFS or HBase. HBase is also a storage location where is a semi-structured and non-structured data can be stored, data can be stored. In HBase, HDFS, we already explained you the Hadoop file, Hadoop distributed file system. So this is how it's things moves in a complete components. So let's take a look at that in Ambari. Here is the Ambari. If I just do that, it will show me, as I already told you, that I already downloaded the Hortonworks Sandbox. So once you download Sandbox, it does offer you that Ambari terminal from. If I just see that it's give me that URL from where I can see the Ambari jobs running, and below that there is an SSH terminal which has been web-based client. So if we just look into that, what is the SSH terminal? If I just see that, it gives me that specific thing where I just need to type my user ID and password. I'm logged into web-based terminal which is given by Hortonworks to connect their machine. So if we go to again on Hambari on Hive, and we can see that now we know what's Metastore of, we know at what Hive server 2 is it, we know that MySQL is written in it. So it's mean that MySQL is the meta server repository. So then web hatchcat, we already told you that it's more kind of the terminal which has been giving support in case of accessing Hive Metastore by an external application like Teradata, Astros, or a number of the other tools which using REST API underline it to get that access. So this is all about that, and then there is a views, couple of views, and this is the JDBC to which we can connect. It's connecting to Zookeeper. Then there is an views available. All the configuration of Hive is being stored, server-side parameters it's been stored in at Hive location and config tab. So if you go to config tab, you can see whatever been set up. So here's all kind of parameters being defined. It's just a summary of that. And if we go on top of it, you will be able to see the advanced parameter in it. You can see the number of different database here which has been offered to store the Metastore. So every configuration related to Metastore or related to Hive is being given in config parameter. So these are the server side thing. Now if we go to client side thing, we can have different view. Hive view 2 and Hive view is an older one. Hive view 2 is a newer version. So it's just a change of that. If we just try to click of that, you can see that it's give you interface which talks about the Hive UI. This is the Hive UI. So if we just want to write any query here, we can write it there and get that executed. This is default is the databases. Few databases are visible there. So there is a list of that. So will be visible there. So on which you have access, these will be accessible from here. So this is one way of accessing that, writing a query from there. And if we go to Hive view 2, it's the same UI from where you can access the Hive, but it's more sophisticated, gives you more information. So that is what the versions comes into play and gives you more options. Let's go to Hive CLI terminal. So on CLI, we do have an option to connect through Beeline and direct Hive client as well. So if I just type Hive in it, we already log into the mode. It will just load the Hive client on the CLI. So we can query from CLI as well. It's gonna take some time, and then it will be loaded, and then we can just run a queries there. So this is at backend side, so it gives you terminal. So if I will write that show databases, it will give me within semicolon sign, it will show me that what are the databases right now available. So we will run queries and do all the practice on this one in upcoming sessions. So same that we have a Beeline connection. So if we want to get that executed from CLI, we can get that Beeline executed, and we do have a command to initiate the CLI to run through an application and get our command executed and get the result output. So if you have Kerberos implemented, then you need to run a kinit earlier to load your Hive CLI. So kinit command need to be executed and your Active Directory password would be required. And then you can type Hive or you can connect to Hive through using VLAN. In case Hive UI, you just, while your cluster is configured with Kerberos, then you just need to click on Hive UI, it will work automatically. But before that, your Ambari need to be having KNet or Active Directory configure, otherwise it won't connect. This is all about today's session. We have given you introduction of Hive and its component. Is it a DBMS or not a DBMS? You just need to follow us on Twitter, Facebook. You can ask any question on YouTube channel comments or Facebook page or on Twitter. We'll try to reply your question. Do subscribe us on all these social medias. So if you want to get an update what we are giving in case of next video, so you can be aware of that. Thanks for everyone. Bye.